Hello everyone, I'm Chengling. Welcome to my structural analysis tutoring section. Today I'm going to talk about a very fundamental concept called axial force, shear force, and bending moment diagram. Specifically today I'm going to just cover the sign convention that civil engineers use in common practice. Alright, let's take a look at this example. Let me choose the pen first. Right. Let's say I have a structure system like this, which is very complicated. Okay. Let's say I have a hinge here. Okay. And then I have some loading condition. Okay, some loading, crazy loading. Okay, and then some distributed load, and then a couple, and then I have a loading like this. And then I want to know the reaction force. The reaction force is pretty simple. You can find it from the equilibrium of the system. And then the problem is I want to know what happened in this internal in this position, okay, in this every position of the beam. So we need to have to make a cut to understand what's going on inside for a 2D system. Alright, for 2D, if I cut a beam, let's say I have a beam, if I cut it, okay, let me enlarge the cross section. Let's say this is a cut. Okay, we will find three forces in this plane, okay, in this 2D plane. The first one is normal to the plane, okay, and then the other one is something like this, transverse to the plane, and the last one is like this. Okay, so we call this, okay, let's separate them together one by one. We call this force the force that's pointing up longitudinally, okay, to the beam. We call this axial force. Axial force. So the convention that we use is like this, okay. When both of them are pointing outward, okay, they're under tension. The beam are under tension. The beam is under tension. So we call this positive axial force. So compression means negative. Second force, the pair of force that you will find is a shear force. Okay, so this one is like this one is like this. Okay, they are either like this or they are like either like this, right? Okay, so which one is positive? Okay, the convention that we use is like this. This is called positive shear. Okay, whenever you see the right side is pointing upward, we call this positive shear force. For this one is downward, so we call this negative shear force. If the right face is downwards and the left face is pointing upward, we call this negative shear force. Alright, the next one is called bending moment. Bending moment is a couple, is a pair of couples. They are either like this, okay, or like this. Okay, for this one, for this pair of bending moment, the arrow is at the top, which means that, okay, the bottom is under tension. Okay, tension. For this one, the top is under tension. Okay, so I means that the bottom is under compression. Okay, so we call this, okay, positive bending moment. For this one, negative. Alright, looks simple, but let's take a look at some important example. Let's see. I have a beam, a vertical beam. Okay, a beam. Okay. Let's say I cut a point and enlarge this cut. Right? How do I call axial force? Positive axial force. Positive axial force is something like this. For this vertical member, so this is a positive axial force. Okay, why? Because this two force is pointing outwards from the beam, from the face of the beam. Okay, so this is a positive axial force, which means that the beam is under tension. So how about shear force? Okay, shear force. Shear force. If you look from this side, okay, you will see that this is left face, this is right face. A positive shear should be something like this. Okay, which also checks whether this is consistent with a person who look from this direction. If I look from this direction, okay, I will call this left face and this is right face. So the right face is upward, so this is positive. So this is a positive shear for a vertical member. Okay, force. How about bending moment? Bending moment is a little bit tricky. Alright. If I look from this side, okay, I will call back positive bending moment like this. Okay, positive bending moment, which means that okay, this is bottom part. Okay, bottom part. This is the center, and then the bottom part is under tension. I will call this positive. But if I look from this side, okay, I will call this bending moment negative. So what I mean is that the side of the bending moment doesn't really matter. Okay, we always consider which part of the beam is under tension. Alright. What I mean is like this. Okay, I want to do a summary first. For axial force, and for axial and shear, the sign convention is important. Sign is important. Okay, because there is no contradiction. Okay, if you say that this is a positive shear, we all can draw it. For example, I have an inclined beam. Okay, if I say that, if I cut this point, if I say that at this point is a positive 10 kilonewton shear. Okay, I will draw it something like this. Okay, 10 kilonewton. All right, positive 10 kilonewton. Right, so this is 10. There is no contradiction. No matter how I look, no matter I look from this direction or this direction. Okay. But for bending moment, okay, bending moment, okay. What really important is which parts is under tension. Okay, the beam. Okay, for the cross section, for particular cross section. For example, okay, if I say that, okay, let's say I say at this point, okay, the bottom is under tension, so I will know that the bending moment is something like this, right? And if I look from this direction, I will call this positive. Okay. If I look from this direction, okay, I will call this bending moment negative. Okay, there are no contradiction. Both of them are correct. Okay, both of them are correct. But it depends on how we look at the beam. Okay, so that's why in civil engineering, okay, we always plot the tension, the bending moment at the tensile side. Okay, plot bending moment at tensile side. which you will not find this in the some standard textbook, okay, about structure analysis. For example, let me go quickly go. If you for simple supported beam, by definition is something like this. The two pinned end, okay. And then you have a uniformly distributed load, okay. The bending moment that you commonly found in the textbook is something like this. But however, in civil engineering practice, okay, you'll find the bending moment to be something like this. Okay, you can see that we draw at the bottom because we know that the bottom part is under tension. Okay, bottom is tension. Alright. If you look the beam from this side, okay, you will see that this is bottom. Of course, if you look at this side, okay, you will say that this is bottom. For this guy, you will say that this is a positive bending moment. But for this guy, you will say that this is a negative bending moment. Okay, because this is at the top, right? Bending at the top. So that's it. Thank you for watching.